Hey guys, so really quickly I just want to walk through some of these story problems and using the bar method. Sorry, I forgot the name of it for a second. So we're going to be talking about using the bar method or a bar model to write an equation, and then using that equation we will solve. So the first thing we're going to do is read through this problem. And I'm going to highlight any important numbers that we might need to remember. So the senior class has 412 students. They are assigned to different homerooms. There are 28 students in the smallest homeroom, and the remaining 12 homerooms have the same number of students.
Bradley, could you come to the main
Sorry guys,
office?
hold on. Okay. So the remaining 12 homerooms have the same number of students. How many students are in each of the remaining homerooms? So when we're using the bar model, we set up kind of this bar, and we're saying like this whole thing that we're drawing is going to be equal to something. That's how we do an equation, right? Equations have equal signs. So reading this, the senior class has 412. So this bar is going to be equal to 412. Whatever's inside that bar is going to be equal to 412. And we know that in one homeroom, so one part of our bar, there are 28 students. And the remaining 12 homerooms have the same number of students. So this was one homeroom right here, and there's 12 more. So we're going to divide our box, actually we'll do it this way, into 12 more homerooms. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Sorry, they got a little small there at the end, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, there's 12. Sorry, they got really small. And we don't know how many students are in each of those homerooms, but we know it's the same number. So I'm going to use a variable to represent that number. I'm just going to use x. You could use a different variable if you wanted. It wouldn't make a difference. So that's how we draw our bar model. And now we need to set up our equation. So what we do is we pull all the parts of our bar model out. So we say, hey, there's 28 plus something that's going to equal 412. Now we could pull out every individual x, so we would have like 28 plus x plus x plus x plus x, and so on and so on and so on. We would do that 12 times. But we could also say, hey, if each of these is 1x, we can just say, hey, there's 12 x's right there, because we can combine like terms and there would be 12. And now we're going to solve for x. So we got an equation, and it's 28 plus 12x equals 412. And now we're going to solve. So if we subtract 28 from both sides, we're left with 12x equals, now this is where we use a calculator if we're not sure about our math.
Eliza Powers, come to the main office. Eliza Powers, to the main office.
Sorry guys. And 412 minus 28 gives us 384. Now x is being multiplied by 12, and we undo that with division. And we solve, we get x equals, and 384 divided by 12 is 32. So there are 32 students in each of the homerooms. So let's try one more. Okay, so I want you guys to pause the video, try this one on your own, and then press play when you're ready. Okay, so now let's think about what we do know. Billy is 3 years older than his sister Anne, and together the sum of their ages is 25, and I want to underline this word sum. How old are Billy and Anne? So sum means that when we add two things together, that's what we get. We get a sum when we add two things. So if we're going to draw a bar model, okay, and we're looking again for the same thing, we want an equation, and we want to solve that equation. So this whole thing is going to be 25 because the sum of the ages is 25. Now, this is made up of two things. We have Billy and Ann's age. So we've got, this is going to be Billy's age. This is going to be Ann. Okay, and we know that Billy's age plus Ann's age is going to give us 25, right? But we need to come up, we don't know what Billy's age and Ann's age are, so we need to come up with that. So since we don't know how old Billy is, we're going to plug a B in for Billy. And we don't know Ann's age either. Now we could put an A in here, but then we would have B plus A equals 25. And because we have two different variables, we don't know how to solve that. But what do we know about Ann's age? Well, we know that Billy is 3 years older, which means that Ann is 3 years younger. So instead of an A, we could say Ann's age is equal to Billy's age minus 3. Now we pull out the parts, so we have B plus B minus 3 equals 25. Now we just simplify and solve. So each of these B's is 1, so that gives us 2B minus 3, because we combine like terms, equals 25. We add 3 to both sides. We get 2B equals 28, and we divide by 2. So Billy's age is 14, and Ann's age was Billy's age minus 3. So 14 minus 3 is 11. And now we can say 14 plus 11, is that 25? 14 plus 11 is 25, so we were correct. So try a few others on your own. There is the practice assignment in Canvas called Equations with Story, or Equations from Story Problems. And there is an answer key available, so you can try any of those, try them out, and let me know if you have questions.